Hello. Can you hear me, Dylan? And hi, Andrew. Alright, sweet. I hadn't realized how awkward streaming is, where you're. Yeah, thanks, Andrew. I appreciate that. The classic mic muted. So yeah, it's not 7 yet. And there's only 13 people here. Uh, I'll start going over the quiz at 7. That's where I was going to start off, because only Ryan Cheng got 100% on this. Everybody else missed something. Close enough. Start teaching us math. Yeah, come on, man. There's 14 people here. I don't present for just any audience. They can rewind. Hater. Yeah, it turns out I'm not a football fan, so no, I didn't know I was streaming in the middle of the Seahawks game. Are they winning, I guess? Because it hasn't technically started yet, Anastasia. And we're like perfectly at halftime. This is fantastic. Oh, also to everybody that's here, I haven't put in the retake grades yet. So if you're thinking you did better on the retake than your grade suggests, yeah, you probably did. I'll probably put those in after this. Oh, sorry, Helen. Yeah, you were the other person to get all 5, so you're fine. It was you and Ryan. Okay, it's 7. Yeah. Up to 22 people. Wow. I gotta figure out how to not be worthless and do this chat thing, but until then, let's go on the quiz here. Alright. So a ton of people did run over rise for this first one, but most people got this right. A ton of other people also didn't go into the right range here, going between 3 and 11, and a fair number of people went between 1 and 3, which was kind of a bummer. But for average rate of change, You just do 64 minus 991 over 11 minus 3. And you should have gotten negative 927 over 8. And a lot of people got here. And then a lot of people went further than this and were sad because you don't go further than this. A bunch of people tried to approximate what f of 7 was, but that's not what the question asks. The question asks what f prime of 7 is, so it's just literally this answer right here. For the next one, using 5 and 7 were the best choices, but if you use like 6 and 8, that's fine, or 6 and 4, that's fine. You just need to do y2 minus y1 over x2 minus x1 for those. And so for 5 and 7, for this version of the test, you should have gotten 4. For the other version, you should have gotten negative 4. Also for the other version, I went between 15 and 17 here, but same idea. And that's the first section on there, which sadly a lot of folks missed. And TJ Tribble says 25. Thank you, TJ. That's very helpful. All right. On to question 2. You just had to cross out the hole in the first one here. And I'm trying to make sure my screencast shows up. Can anybody give me feedback on... Oh yeah, it does show up. Sick. Alright. I'm watching myself watching me talk to you all too, also, on dual screens. That's very exciting. So if you back to the top, you can cancel out an x minus 7. And then you just plug in 7 and you get 9 in this one, and in the other version you got something different. But it was the same idea. You just plug in whatever your limit is once you cross out the hole. Over here, a ton of people didn't know their trig. But sine and cosine aren't the same at 0, no matter what, so that was undefined. Negative pi over 2 is when x is less than 0, so sine of negative pi over 2 is negative 1. And limit as x approaches pi of f of x. That's these two guys, and tangent sine over cosine, so it's basically never going to have the same value as cosine. So that's undefined. But at pi specifically, cosine is negative 1 and tangent is 0. So that was no good. Okay. On to the next question. For this one, you get x minus 1 squared, and it doesn't matter if the inside is 0, it doesn't matter if the inside's negative, so this one was all real numbers. The next one was 1 over x squared, whoops, minus 1, if you plugged x squared plus 5 in for x here. And so then x just can't be 1 or negative 1. On the other version, I had x squared minus 4 on the bottom, and so it just couldn't be 2 or negative 2. And for our last one, you have 1 over the square root of x minus 1. And x just needs to be big enough so that the inside of the square root is not negative, and also is not 0 because you can't divide by 0. So x just needs to be bigger than 1. And that was it for that one. And our bottom one, this one kind of wrecked some folks. At 0 in this version, negative 11 over x, those were our two smallest terms. They're also the farthest right terms. And we always look at our smallest right or our smallest terms when we're doing limits at 0. We look at our biggest terms when we're looking at limits at infinity. A lot of people looked at the biggest terms at the limit at 0 here, and they were sad because they didn't get it right. But yeah, you get 11 over x, and you plug in 0, and on the left side it's like negative huge numbers, and on the right side of 0 it's positive huge numbers, and so it was undefined, this one. In the other version, there was no constant term, and so it was actually the ratio of negative 4 to negative 1, and so the answer was 4 in the other version. And our last question, it's just the ratio of the biggest terms. This question was quite a bit easier than the other one because there was a 4 inside the square root in the other one, and that one threw a lot of people for a loop because they forget to square root the 4. But in this one, it's just 2x cubed over x cubed, if you pull out the biggest terms. And that's just 2. Alright, I'm going to go back and check on chat, see how that's going. Get wrecked. Oh, rough. Yeah, a lot of people got wrecked, but the good news is we retake all those quizzes next week, so everybody can do better, hopefully. That would be fantastic. So I just want to go and look at the other quiz that's like this. The other version. I talked about a few of the differences. And where did they lie? Well, just jump on in here. So in this one, you were just going in between these, so it was 11 minus 44 over 2, which was negative 16.5. And people went further, and they were sad because you don't go further. That's the slope, or the approximate slope there. And then in our next one, we approximate the slope, and the 2 points I used were -1 and -3, and you just plug those into this function and get the slope. So if you plug -3 in, you get 25 over 2, because it's -5 squared, minus 3, and when you plug in -1, you get 9/2 minus 3, and you just do y2 minus y1 over x2 minus x1. In this case, you get -4, because this one is on the left side of the vertex, and so I did one on the right side and one on the left side for my 2 different versions. And so yeah, we were hoping to get over here. Let's see. I went over the trig. The trig's kind of dull at this point, but in this one, sine and tangent do have the same value at 0. And at pi over 2, you just had to find what the tangent was, and the tangent of pi over 2 is 1. And lastly, the limit at pi, tangent and cosine don't meet, and so no go. Okay. Zooming down. This one was always good, because similarly to the one in the other version, cubing something, it doesn't care. There's no bottom of the fraction, no natural log, no square root, and no piecewise, so we have none of the problems. This one was 1 over x squared minus 4, so you couldn't be 2 and -2. And this one had a natural log instead of a square root, but it's basically exactly the same. You can't put 0 or negatives. It's never continuous at 0 or negative values. So x just had to be bigger than 1. And then down here in the bottom part, I talked about this when I was doing the other one, but -4x over -x is a positive 4 that this thing is approaching at 0, looking at the smallest powers. And in this one, yeah, this one threw a lot of people for a loop. 4x cubed and 4x to the 6. They pull it out as 4x cubed and 4x cubed, but it's not, because the square root of 4 is 2, and so the answer is 2 in this one. And so looking at the 2 versions, people did a lot better on the other version of 4 than this one. Otherwise, the differences in the scores were not that stark. Hey, this is actually pretty helpful. Yay! Why are there 2 Andrew Chappelles? I'm so confused. And Andrew, I don't know how to ban people yet, so I couldn't do it if I wanted to. Alright, I did want to look at the class averages just for fun, so you know how people did on it. Can I zoom in on this? Yeah. So period 3 and 4 cleaned up. They had the same version of the quiz. Period 1 and 2 had the other version, so maybe some slight version issues. You can see they did quite a bit better on section 4. And honestly, section 1, which surprised me because they were basically exactly the same questions. There was actually no difficulty difference between those. So maybe the word got out at lunch or something. But yeah, that was the primary difference we saw in the quiz versions. So hopefully pretty balanced. Yeah, not sure what happened in period 2. That's quite a crater there. I'm not sure anything from Twitch works here. I have no idea, actually. Boo, third period? Oh yeah, third period beasted. They did quite well. So, if people could send me some direction about where to go next, I was planning to start with the quizzes, and then, I don't really know where to go after that. Maybe the review? I have a whole bunch of files on my desktop ready to roll. Anastasia, I think it was 0.05%. It was like so little of a difference. Yeah, 0.05. I can do a window capture instead of a screen. Yeah, I'm not sure that's better though. Okay, review. Well, I know what the lag time is now. It's like 20 seconds. Holy smokes. So yeah, to the review. Yeah, that one. I guess I could just chunk through this thing. Alright. Just do the review. Alright. Okay. First one here. So it says we have a y equals 2 asymptote to our graph. Which of the following are true? F of 0 equals 2, that's ridiculous. There's no reason that would be true. That's like the y-intercept. That has nothing to do with the horizontal asymptote. It says we can't be equal to 2 for all x. This one's kind of reasonable, but there is a case where this could not be true, and I talked about it to some people in class. But that case is if I took a sine of x over x graph, and then I just added 2 to it, all of a sudden, its asymptote is now up here at 2, but it's going through the axis multiple times and just getting closer and closer and closer. My picture is a steaming hot pile of garbage. But the whole point is it can go through the axis and still have a horizontal asymptote. So asymptotes are not something you necessarily don't touch. It's just what your end behavior is out at infinity. Which kind of leads us to our next ones. Well, f of 2 is undefined. Yeah, the x value doesn't matter. We can plug in 2 if we want, maybe. And then our limit as x approaches 2 is infinity. That would be a vertical asymptote at x equals 2. So that's not what our case is here. We have a horizontal asymptote y equals 2. And then lastly, our limit at infinity is 2. Yeah, that's the one thing that has to be true, is that one. And this is an actual AP question off the 2003 exam, I think. So yeah, it's pretty tricky. You can see how people only get like 40% on this test. Okay, the first question there was in the next section. Number one here is a square root one. So the way we undo square roots is with the conjugate. So we multiply by root x plus 5 plus 3. And so if I multiply by that, multiply by root x plus 5 plus 3 over itself, then what I get is I get x plus 5 minus 9 on top. because I get a difference of squares, just this times this minus this times this, which is the whole point of doing a conjugate. And on the bottom, I just get everything else. So I get x minus 4 times square root of x plus 5 plus 3. And the nice part now is that on top I get x minus 4, and on bottom I get x minus 4, and those can kill each other, and I just get 1 over square root of x plus 5 plus 3. And if you plug 4 in, you get 1 over 3 plus 3, which is 1/6. That was honestly one of the most brutal problems in there, just because the conjugate stuff kind of takes a while. Our next one, we get, if you factor the top, you get 2x plus 1. No, did I do that wrong? Oh, garbage. There's an eraser here. I can make it look like I'm not an idiot. All right, so I know we have a minus 3 here, and a plus 1 here. And I just did the cheaty thing where I know minus 3x and plus 2x add to a negative x. Yay! And that's over x plus 1. And if I was not a dingus, I would have realized that x plus 1 is on the bottom, and so x plus 1 should be one of my factors, but I am a dingus, so whatever. And I cross out those x plus 1s, and I just plug in negative 1, and negative 2 minus 3 is negative 5. And I'm writing so big that I am just blotting out all this stuff. Our last one here, this one, I think this problem is really cool. It's cosine of x over cosine of x over sine of x, which is what cotangent is. Which means cosine of x over cosine of x, those kill each other. And 1 over sine x is just sine x. So what's sine of pi over 2? It's 1, yay. So the question gets really easy if you simplify it. Okay, we have a really nice next question. The power on top is 2. The power on the bottom is 3. And so the power on bottom is bigger, and we're going to infinity, so we're going to 0. So justify my answer, I did it out loud. You can't, though. Alright. Yeah, I'll finish up this problem, and then I'll check to see if I'm, like, blazing too fast or something through this. Okay, so, this is something we didn't really cover in class, but it's kind of a pretty family-friendly concept. If your limits have values, you can subtract them. So 3/2 minus 1/2 is 1. And if you multiply 3 by the limit of g of x, you get 3 times a half, or 3/2. And yeah, it's pretty nice. Alright. Let's check on the chat here. Oh, never mind, Kennedy. That's good. Whew. Intermediate value would be good. Kennedy does my homework for me. Yeah, rip. How are we supposed to justify it? Power on top is smaller than power on the bottom. That's enough to justify it. Yeah, I realize blaze maybe not the best word choice there. Okay. I'm going to go down to our next section here. Alright, so yeah, we have this big A through E multiple choice, and we got to figure out where this thing is defined. No, there's no square roots, there's no natural logs, there's none of there's no fractions, there's nothing that would cause us to have a problem besides the piecewise function. So all I do is plug in my edges of the piecewise function. So like at 0, I'm at sine of x and x squared, they're both 0. So we're good, that one's cool. At 1, it's in these two functions, x squared and 2 minus x, and I get 1 and 1, that's good. Those are exactly the same value where they meet at 1. At 2, I plug in my guys on either side, this guy and this guy, and I get 0 and -1. Yeah, that's no good. That one's bad. So it says which of the values is f of x not continuous, and we say yeah, it's at 2. That's the bad one. All right, in 16, it says find the vertical and horizontal asymptotes, which, spoiler, definitely on the test. And so this is fantastic practice. Vertical asymptotes are where the bottom's 0, so that's -4. Where x equals -4, that would be our vertical asymptote. And then horizontal asymptotes are either the ratio of the leading terms, when the powers are the same on top and bottom, or if the power is smaller on top at infinity, we are going to 0, so that can also be a horizontal asymptote. And in this case, the power on top is 1/2, the power on the bottom is 1, and so we're going to 0. So y equals 0 is our horizontal, and x equals -4 is our vertical, so that's A. Alright. This one here is surprisingly nice because if you know that the biggest terms are what you look at when you go to infinity, all you do is look at these two terms and say, hey, 6n squared over kn squared needs to be equal to 1/2, so k just needs to be twice as big as 6, which is 12. Wow. Nice. Alright, and I'm going to head back and look at the chat because I'm incompetent and I'm not split screening this as much as I could here. Can we go over the actual test on here? We usually go over the actual test in class. I could definitely see uses for this. I could do it in class. I mean, if I was like super slacker life, I could just do it in the first class and then just like show the one I did in the first class in the other classes. That sounds pretty slacker life. There might be some benefit to that. And then I could have that posted online. How long do you think the actual test takes? Yeah, so I'm really, really bad at estimating that. I usually take how long it takes me to do it and multiply by 4. But with tests, I'm not 100% sure. Oh god, Andrew, no, don't do that. Oh, go over the actual tests right now. Oh yeah, I was joking about that earlier today. No, I'm not gonna go. And calculus sucks, really? How do I ban people? Can I like click on? I'm too lazy. Yeah. Hey, I'm giving you intel on the test. Let's go back to this review thing and look at some stuff. I mean, the tests, I went over and like proofread it today. There's a ton of limit stuff, like lots of crossing out holes and evaluating where things are continuous. It's like, man, all that stuff on the quiz, all that stuff is on the test. So if you can do the quiz questions, you can do the test questions. And that's really what you should be worried about going into the test. And a ton of these questions in this review are like actually perfect examples of what you're expected to know. And no, I'm not going to go over the test ahead of time. That would be so useless. Alright. So our biggest powers here are the first two guys, and they have a 1/4 ratio. Wow. They're both x cubes. For which of the following does the limit as x approaches 4 exist? Well, definitely in this one. It's approaching, whatever that is, 3 from both sides. In our next one, yeah, same. Also approaching 3. Different looking graph, but whatever. And in our last one, no good. We are approaching 2 on one side and 4 on the other side. So that one's garbage. So it's just 1 and 2. And that's D. Another actual AP test question, I think from 2003. Alright. For the next, find the limits and justify if needed. So we're finding the limit at 3. So basically we just need to see if these meet at 3. And this one is 5/2 at 3, and this one is 6/3, which is 2. So 5/2 is not 2, so you say undefined. Yeah. That's a terrible undefined. That's better. Okay, and then as we go to infinity, we just look at those big powers. It's going to 2. Talking about horizontal asymptotes again, when we do a limit at infinity, we are always finding what the horizontal asymptote would be if it's anything that isn't undefined infinity or negative infinity. So whatever this value is, that is our limit at infinity, that is our horizontal asymptote, like y equals 2 in this problem. Or up here in the top, y equals 1/4 would be our horizontal asymptote. And that's part of the reason we do limits at infinity. Use the intermediate value theorem to show 2x cubed minus 3 has a 0 on the interval 1, 2. Yeah, okay. Intermediate value theorem says that on an interval, you have to go through every single y value in between. So what we do to prove this is we plug in 1 and 2 into this function. And if I plug in 1, I get -1. If I plug in 2, I get 13 for 2 times 8 minus 3. Now, it's saying we have to have a 0, so at some x value, we need to have a y value of 0. And if this thing's continuous, that should definitely be true, because between -1 and 13, we have to go through 0. And if we look at the function, it absolutely is continuous everywhere. It's just a cubed function. We can plug anything we want into it. And so, because of the intermediate value theorem, there needs to be a value. You can also prove what value it is. So if they ask you a question like this, you should probably go above and beyond and say, hey, if I plug 0 equals 2x cubed minus 3, like the spot where the y value is 0 will be whatever x is when I solve this. So I add 3 over, I divide by 2, so 1.5 equals x cubed. And so the cubed root of 1.5, that would be the x value where this is true. So a little grody, but yeah, that's how the intermediate value theorem works. It just, there are all the y values in between. Just use it to show that. And you need to have a continuous function to do this. So if they gave us something that was discontinuous on that, like if there was a 2x plus 3 on the bottom of or a 2x minus 3 on the bottom of a fraction in between, that would give us a undefined at 1.5. We absolutely could not use the intermediate value theorem because it is discontinuous. Or if we had some sort of piecewise garbage that split up our interval, we couldn't use the intermediate value theorem if it made it discontinuous. Hopefully that answers your questions. I know there were a few questions about the intermediate value theorem in the chat when I last looked. So time to go back. Support for Ryan. Seeing our quizzes before the tests. Yeah, no, we're definitely going to do that in class. I am definitely going to hand back the quizzes. Would just doing one proof give me full points for 13? Yes, it would. In every place I've seen the intermediate value theorem on the AP tests, who decided to dislike this? Sorry. Every time I've seen an intermediate value theorem problem, if you just mention the intermediate value theorem and talk about how the function's continuous, it's like really hard to lose points for those ones. So if you just say, hey, on either side, it's smaller on one side, bigger on the other side, it's continuous, it's got to go through them, you're good to go. If you actually prove the point, you're going above and beyond that. All right. The test is Tuesday. Yes, it is, Krista. Thank you, Andrew, for your stalwart support. Are there going to be step discontinuities? Yes. Step discontinuity is like in 79 here. There was a step discontinuity just right on the screen here. The third graph for 79, that was a step discontinuity. So yeah, any one of our piecewises that don't line up, like all those trig ones on the quiz, were step discontinuities. So absolutely we will have this. Can you go through more intermediate value theorem problems? Yeah, sure. What do most people get wrecked on? Oh, that's a hard question. Honestly, it's the most recent quiz sections that usually wreck people, the ones people haven't had a chance to mess up on yet. So quiz section 4, so the infinity and zero limits are what people mess up a lot. Continuity and discontinuity, that section tends to be one of the more retaken sections, although I think we got really good averages in that section this year. Yeah, besides period 2. Everybody got like a B average on that, so maybe that won't happen this year. I mean, honestly, on the quiz, people got wrecked on average rate of change, which was a bit of a bummer. It really was pretty decent. Besides, quiz section 4 routinely just wrecks people, because you kind of have to have a pretty strong understanding of parent graphs to do really well in quiz section 4, and that's why we see the D averages on it. So what do people get wrecked on? The same stuff they get wrecked on quizzes, because the test is not a whole lot unlike the quizzes. Also, quick shout out to our people watching the stream. If you don't know how to complete the square, you should learn how before Tuesday, because that's definitely on there. And we didn't quiz on it in class, but we took notes on that section. And I can run through one of those maybe after I finish this review. And, okay, intermediate value theorem problems and that are on my list. So I'm going to go back to the review now. I don't know what I'm going to be doing live streams for, because this is the first time I've ever used one. So, yeah. I would like to use this more if it's really helpful for people, so I'm hoping to get feedback from y'all, and whoever watches it maybe late. Alright. I want to go down here and do this last one, because this question was actually really excellent, in my opinion. So, going back to the screen sketch. Alright. What are the zeros of f of x? Zeros are roots or intercepts, so they're where our top is 0. And so we just go to our function here, and we like factor this thing out completely, top and bottom. And so I can factor out a 3 on the bottom. And I can factor out an x right away on the top. Now I have to keep going, because each of those quadratics can be factored further. So I get x times x plus 3 times x minus 1 on top. And I get 3 times x plus 2 times x minus 1 on the bottom. And I have a very clear hole right here at x minus 1 over x minus 1. So those aren't zeros. My zeros are 0 for the x and negative 3 for the x plus 3. So x equals 0 and x equals negative 3. So again, I had to cross out the hole in order to do this, the same way I have to cross out the hole to do the vertical asymptotes or to evaluate the limit. You just really should factor these things if you can. So what are the vertical asymptotes? There were my bottom 0. It's basically just negative 2. So x equals negative 2 would be my vertical asymptote. The in behavior model of f of x is the function g of x. This is something we didn't cover in class, but I thought was really cool. So sorry. So we haven't talked about in behavior models. I've never seen it on the AP test, but it's a actually really good way of thinking about the problem. So an in-behavior model is just what does the function look like as we go out to infinity. The power on top is bigger than the power on the bottom in this, and if we just look at the biggest powers, which is how you do in behavior. You look at limits at infinity, so you look at the biggest powers. You just look at x cubed over 3x squared. Those are the biggest powers in our function. And if I simplify this, it looks like x over 3, which is a function that is called g of x. So 1/3 x, that's our g of x. And that's what the function's going to look like as it goes out to infinity, because the power on top is 1 bigger than the power on the bottom. It's going to be linear and going up towards infinity. So yeah, that's that question. And it asks, what is the limit as we go to infinity of f of x? Well, the power is bigger on top, so I just talked about that. It's going to infinity. And then what is the limit of f of x over g of x? So this one kind of goes with understanding what the heck this means. Because if you know that this is what our function looks like as we plug in massive numbers, because it's what our ratio of our leading terms is, then you know if we divide these two things that are going to look the same as we go out to infinity, then you're just going to get 1. And so that was the answer to this. It's just 1. All right, I'm going to head back to chat to see how this was received. Are sections 5 and 6 on the test? 6 isn't, 5 is. But 6 helps you with 5, so yeah. Yeah? Oh, I lost some people. Can you do C and D again? Yes. How did I get -3 as a 0? I factored the top, and the top factors to x times x plus 3 times x minus 1, and the x plus 3 is where the 0 comes from. Are those last problems going to be on the test? No. No, they aren't. But understanding that two things that look the same are going to go to 1 as you go out to infinity is pretty cool. Kennedy, you can make people moderators for this chat. Yeah, it wouldn't be you, Andrew. Do we need to be able to do part C? No, we don't. Alright, so let's go in and look at C and D again, because I'm getting a ton of questions on them. So I'm just going to redo those. Alright. Alright, so for C, it says the end behavior model of f of x is the function g of x. So I want to say, I know that this function, because its power on top is bigger than its power on its bottom, is going to go to infinity, but I'm curious what kind of shape it takes as it goes out to infinity. Because it's going to be doing, like, around 0, it's going to be doing some janky stuff because it has, like, a cubic over a quadratic. I don't have no idea how it looks there. But as it settles down with whatever its end behavior is, it's going to look like something as it goes up here to infinity. And I'm trying to figure out what that something is. And to find that, I just take my ratio of my leading terms, the dominant ones, as I go to infinity, and they're x cubed over 3x squared. And I go, I'm just going to divide these and cancel out the x squared on top and bottom and just get x over 3. And so I can say that this thing, as I plug in really big numbers and these terms don't matter in my original things, it's going to look a lot like x over 3. So it's going to look like a linear that's not quite 45 degrees, a little shorter than that, as we go up to infinity. So it's still going to infinity, but it's going to infinity slower. It's why when people say, what's infinity divided by infinity, I say, it depends, because it depends how fast it's going to infinity, because something that's going to infinity at 3x would be going way faster than x over 3. So that's why we need to know what the ratio of those is. And then looking at D, The limit at infinity is very easy for f of x because it's just bigger power on top than on the bottom. And so that was going to infinity. And for f of x over g of x, because this function is going up to infinity at an x over 3 rate, and g of x, which I said was x over 3, is going up at an x over 3 rate. G of x is just this line that goes straight out here. Instead of doing all the janky stuff around 0 and 10 and small numbers, it just goes straight to where this guy ends up. It's basically its slant asymptote, which I think you guys did in pre-calc. So if these guys have exactly the same slant asymptote, because g of x obviously goes to x over 3 forever, and this function goes to x over 3, because that's its ratio of its leading terms, then if we divide those two, we're just going to get 1. They're exactly the same thing. They have exactly the same asymptote. And hopefully that did a better job explaining that. Do you have an art degree? Ouch. No. Is the test multiple choice or show your work style questions? It is show your work style questions, definitely. Yeah, there's a lot of free response questions. It's going to take me a long time to grade. So, yeah, I'm lamenting that. But, yeah, I mean, I think it's a pretty representative test of what we've done in class. There definitely is all of the algebra stuff. I have... I don't know, like a section for each one of them, and maybe each one of those algebra sections is like a half quiz section in length, if you want to approximate those. And then the limits, it's kind of heavy on the limits comparatively. So there's a whole bunch of limits at infinity and 0 and at numbers where you have to cross out holes or piecewise or finding asymptotes or any of those sort of things. There are some multiple choice questions on it. There's like, I don't know, 5 or so. There's also an extra credit question that I'm pretty excited about. I've found one that I really like. The test is like 25 questions. Not counting the extra credit question. That is just there for the people who get bored at the end. So 25 actual math questions. Oh, calculus sucks. I don't know who you are. Somebody asked me about something else. Oh, they wanted me to do more intermediate value, I think. So I can do that. Are there limits with logs and whatnot? Yes, yes, yes. Can we get a face cam now? No, we're good. Okay, so is the extra credit going to be doable with your current calc knowledge? It does not require calc knowledge, but it does help to have calc knowledge. It's just very doable without the calc knowledge. Okay, so let's just make sure it's not pre-recorded. Yeah. Alright, I'm just going to go to a scratch pad. A lot of intermediate value theorem problems, they just give you a function. Oh, apparently I don't have a pen. Here we go. Alright, so they give you a function like f of x is equal to 4x squared minus natural log of x. And this thing looks terrible. And they say, okay, does the intermediate value theorem guarantee a value on the interval 1 to 5? And they want the value to be, does it guarantee 10? Does 10 happen? Does y equals 10 happen? This is how intermediate value theorems are often phrased. Even on the AP test, they're going to give you some janky function in the problem, and like part B or C is going to be, hey, does the value of this function ever have to be 10? And you have to go in and figure out if it does. So the easiest way to figure out if it does is to actually plug in the points. And if I plug in the points at 1, I get 4 times 1 is 4. minus natural log of 1, or 0, because natural log of 1 is 0. So that's one of the points, and the other point, I plug in 5, and I get 100 minus natural log of 5 for my y value. Natural log of 5 being like less than 2, so I don't care about it really. This is like 98-ish if I had to ballpark it. And so yes, between 4 and 98, there needs to be a 10 that happens. I also need to add that yes, f of x is continuous on 1 to 5. So that's an important quality, that it is continuous there. And I know it's continuous because I can plug anything I want into a squared, and in a natural log, I just can't have negatives, and I put in positives, so I'm happy. And so, yes, I can guarantee this. And if you have to solve this, you better be given a calculator, because it has a natural log in it, and that's mean. So, I mean, that's really how these intermediate value theorems work. It's like, they'll ask you if some value has to happen that's in between yours, or maybe it's not, and you say no. Say if I asked if y equals 100 happens, you'd be like, no, it doesn't happen, because 100 is bigger than 98, so it doesn't necessarily happen. Now, if we had this function, and here's 1 comma 4, and here's 5 comma, I'm going to call it 98 for laziness reasons, then in between these, it could be doing some crazy stuff as long as it stayed continuous. Maybe we don't know that it does this, and it could be 100 at some point in this interval. But all we care about in the intermediate value theorem is, does it have to be 100? And no, it doesn't have to be 100, because all the intermediate value theorem guarantees is that it will be all of the values between 4 and 98 are 2 edges of our interval. That's how the intermediate value theorem works. That's why it's called that. Let's see how that was received. So we're only given a range of numbers usually? Yeah. And in free response problems, it's often like that. Oh, do a complete the square? Yeah, that was the other one. I would thank you for reminding me, V. So yeah, let's try completing the square guy now. I like completing the square. It's family friendly. Did I miss anything on here? Definitely need moderators. Oh, rip. Alright. Can we review section 5? Oh, sure. Yeah. We'll do one like that after this. Okay, so first one I want to do is the completing the square. So, I'm going to go back to my sketch pad. Let's get rid of all this garbage and start again. Alright. So, the completing the square problem is really easy on this, so I won't do anything too janky here. Let's say I get 5x squared plus 10x minus 37. And you look at this and you go, wow, this is horrible to factor. Yeah, that doesn't matter. We're completing the square here. So if it says complete the square, we're putting this in vertex form. So I can either ask it as complete the square, or I can say put it in vertex form. So these are the same thing, and I can do these interchangeably because vertex form is why you complete the square. It's also how you solve some questions, or how you graph this thing. So we're just graphing this parabola. And hey, its y-intercept is negative 37. Wow, what a beautiful y-intercept. Alright, so first thing I do. The way I do these is I pull the 5 out of these two terms because it just seems nicer to do that. There's a completing the square method where you don't pull the 5 out and you just do like negative b over 2a and all that garbage. But I think it's easier to just pull out whatever's in front of x squared. So that's how I pull out the 5. Now a lot of people try to do this to factor problems and it works out really poorly for them. But here it's really helpful because all I need to do is figure out what square gives me x squared plus 2x. And the way we do that is if your coefficient of x squared is 1, you just divide 2 by 1. Or, sorry, 2 by 2. You always divide the b term by 2, and you get 1. And then x plus 1 squared is your square thing that gives you x squared plus 2x. In fact, it gives you x squared plus 2x plus 1. So I need to account for this plus 1 by jamming it into this parentheses so that I can complete my square, and it's going to change this number. So if I rewrite this, I get y equals 5 times x plus 1 squared. And I have this 1 that's multiplied by a 5 here. So really, I added a 5 in this parentheses. So I'm going to need to subtract a 5 on the outside of the parentheses to make up for the 5 that is inside the parentheses. The 1 that's multiplied by the coefficient. And so I get that it's y equals 5 times x plus 1 squared minus 42. And I mean, honestly, this is about as complicated as I would make this on the quiz. This one is representative difficulty. It's not going to get harder than this. There's always the easy case, like y equals x squared plus 4x minus 7. I'll just go through this one really quick because it's pretty easy. If your coefficient's already 1 of x squared, you just divide the b term by 2. You get x plus 2 squared. That term is x squared plus 4x plus 4 if you multiply it out. And we have this 4 that isn't accounted for up here. So I need to put this 4 here and affect this term by subtracting 4. So we get y is equal to x squared plus 4x plus 4 minus 4 minus 7. Where this minus 7 is this, and this minus 4 is for this plus 4, because I just added in this 0 equality to make it so I could complete the square. And you just get y equals x plus 2 squared, because that was the whole point of doing this whole thing, and minus 11. And I mean, the main point of doing this is negative 2 comma negative 11, that's our vertex, negative 1 comma negative 42, that's our vertex. And we're super happy with that. That's how completing the square works. I'm just going to ask you to complete the square. I'm not going to make you like graph it or find the vertex or any of that garbage. And back to the chat. Bad grammar. He divided by the wrong number. What? I don't think so. All right. I'm going to head back and do a quiz section 5 problem. So heading into my sketchpad, I'm going to trash all this stuff. And I mean, a pretty representative quiz section 5 problem is take negative 2x squared minus 4. We'll do this function. And do the limit definition. Okay, so the limit definition of the derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. For quiz section 5, you will absolutely need to know this. For a test tomorrow, you will need to know this. So on this question, you're going to be given the first line here, just the function, and do the limit definition. And you need to know this piece for that. Remember, this piece is literally just y2 minus y1 over x2 minus x1, and we're limiting it so that y2 and y1 are the same, and x2 and x1 are the same, which is what delta x being 0 gives you. And then algebraically, stuff cancels out, and we actually get an answer because we can divide by 0 if we can cross it out. So let's plug some stuff in. The way you do this is you always plug in x plus delta x, where x is in the original function, not the other way around. A lot of people feel tempted to write this garbage and then multiply it by x plus delta x, and that goes super sad directions. So if we plug this in, we get the limit as delta x approaches 0 of -2 times x plus delta x squared minus 4. That's f of x plus delta x, so all I did was plug it in where x was. Minus, in parentheses, -2x squared minus 4. Just f of x. Over delta x. Nothing's changed there. And I have to do some serious quadratic expansion here. I get -2 times x squared plus 2x delta x plus delta x squared when I expand the squared. Minus 4 plus 2x squared plus 4. And all over delta x, and I should put my limit here. Alright, so stuff should die now, and stuff does die. The -2x squared is going to die with the positive 2x squared, the -4 is going to die with the positive 4, and I can just rewrite all my remaining parts. Another quick reminder that everything should die in f of x. f of x should die. When you get to the step, because everything should cancel out between those. If it doesn't, you've done something wrong. Alright, so limit as delta x approaches 0 of -4x delta x plus -2 delta x. Why did I write plus? Squared. Alright. So it's just these two terms, and I multiplied them by -2. And that's over delta x. And the nice part now is that I no longer have to divide by 0 because I can kill a delta x in every single term. Please don't be the person that thinks you can cancel out delta x if there isn't a delta x in every term. If I have a plus x cubed here, I've done something wrong. I can't do this. But I don't, so ignore that. In this case, in this problem, I get -4x minus 2 delta x as my remaining part. I can plug in delta x approaches 0, so this just goes to 0, and I get -4x. Which I could have known just from the beginning if I knew how to take the derivative of -2x squared, which I do, and it's just -4x, so I could be like, boom, I checked my answer, yeah. So you should totally do this on Tuesday on the test. You should definitely check your answer with the power rule, because you will have some sort of powery thing. On the test, I'm definitely not going to give you the 1 over x kind or the square root of x kind. Just don't be too afraid of those kinds. Although they're not that bad. For these, you always do common denominators, and for the 1 over x's, and for the square roots, you always do difference of squares. So multiplying by the conjugate. Alright, let's see how that was received. I don't like that formula. Rip. Will you always be able to cancel out the delta x? Yeah, or it'll just go away. Can we just do the power rule and skip the BS? No, actually, no. I mean, honestly, Dylan, the most missed question of the year, every single year, on the actual AAP test, is the limit definition problems. Every single year, and it's why we do those ones at the bottom of the page that aren't the long way out. But the reason why I do the long way out is it's how we do derivatives that we don't have shortcuts for. Like in this class, you learn a whole bunch of shortcuts. Like we're going to go through and do products, quotients, things with insides. We're going to do natural logs. We're going to do exponentials. We're going to do other functions, and we just can't do that. Oh yeah, sorry Nicole, you don't get a calculator. There are some functions that we still can't take the derivative without the limit definition. And if you program and you're doing really janky, huge functions that are awful, you just do the limit definition. And so they teach the limit definition because in most work settings that I have used calculus, I have used the limit definition and not normal calculus. I use the normal calculus like tests my theory, and then when I go to program it or put it into use, it is the limit definition. Let's see if I missed any questions here. Please answer Annabelle's question. Crap, what is Annabelle's question? Should we memorize what the function looks like? What that function looks like. The f of x plus delta x thing? If you memorize what that thing looks like, you'd never need to, like, memorize the function. Why not fair? Do we ever get a calculator in this class? Yes, absolutely. But the problem with the AP test is 65 to 70% of the AP test now is no calculator. And so we actually do a crud ton of no calculator work this year. If you look at the actual breakdown on the test, 30 of the 45 multiple choice questions and 4 of the 6 free response questions are no calculator. So what we're preparing for is very much a no calculator experience. Later this year, we're going to mess around more with doing a calculator experience because we'll be more ready for that. Oh, that's hilarious. WTF is banned, craft. Kennedy, you're making me sad. Well, I'm sorry, I guess. I can't say that people who have taken my class to get a lot better at mental math. What am I always laughing at while we're taking our tests? Oh, while you're taking quizzes, I'm often looking at like 538, which is a political commentary. And so, thanks to our boy Donald, there's a lot of funny material on there pretty regularly. So, that's often what I'm laughing about. So, hey folks, is there anything else I should do specifically? I'm going to wrap up like soon. I can do like one more thing before I head out. So if somebody could point me a direction, I'll do that. But otherwise, I'll head out and put all your retakes in the grade book. Limits with logs and whatnot. Oh, you hating on my breathing? Ouch. Start over and dumb it down. Oh. Teach me Java? I don't know Java. I do C++. Ugh. Oh, the cosine over cotangent one. Okay, we can go there and then look at a few natural logs. I'm not going to join your Minecraft. What kind of question is that? Alright. Minecraft's a stupid game. Alright, so just looking at one of these because I got a question about this and they're too lazy to go back and look at the earlier stream. This is cosine over sine with x's in here. And cosine divided by cosine is just 1. So this is 1 over sine, which is just sine. And so it's just sine of pi over 2, which is 1. And that's that question. Now, people were saying limits with logs. I just blazed through that. So I want to go back to my sketchpad to do limits with logs. Limits with logs are super duper family friendly because most logs you don't know the answer to. So in most cases, you could just talk about how they're not defined at some points. So if I have limit as x approaches negative infinity of x plus natural log of x squared over 4, and I'm trying to evaluate if this thing has a limit at negative infinity, I can be like, heck yes, because negative infinity squared is positive, and I'm not allowed to put zeros in natural logs or negatives in natural logs, but I am allowed to put positives, and positive infinity squared is a positive number, so this would be going up towards infinity. Now, more questions that maybe would come up is, let's say I have a piecewise, and I have log base 4 of x, and I have x squared, and this is for x is less than or equal to 0, and this is for x is greater than 0. And maybe I ask you, where is this thing continuous? So where continuous? Well, I do my thing where, okay, this is sick. I'm actually plugging in x is bigger than 0 into my log, so I got no problems there. I'm succeeding at the log thing, because I'm not allowed to have zeros or negatives, so bigger than 0, totally fine. Okay, but I have to evaluate at 0 because that's one of the piecewise problems, is that piecewise functions I gotta evaluate at where their joint is to see if that works. If I plug 0 into x squared, I get 0. If I plug 0 into log base 4 of x, log base 4 of 0 is like super undefined. In fact, log functions that are just naked like this, like natural log of x or log base 10 of x, just normal log functions, start asymptoting to x equals 0, and then go up and eventually go to infinity, but like super slowly, like slower than a square root does. So if I'm looking at what this value is going to be down here, like this thing is going to negative infinity on this side of 0, so it's pointing at negative infinity, whereas this one's pointing at 0. That's like super not going to the same place. And so this thing would be everywhere but 0. If I wrote this interval, I could say x is not equal to 0. That would be pretty good, or all real except that. Or I could just say from negative infinity to 0, and from 0 to infinity, this thing would be defined. And hopefully that answers people's question on that. Yeah, that's OBS. There we go. The toddler problems on 530. Oh, the Riddler toddler problems. I love the Riddler problems on 538. I do a whole bunch of those. The quiz question is not one of those, though, because I was kind of hoping somebody else knew about those. Those are really awesome. Last week's were way too easy, though. This week's are much better. And the Seahawks are winning, so that's great news. So go watch the game. Have fun. I will see you guys on Tuesday when I will give you back your quizzes. If you're curious about your retake scores, those are going in tonight. Yeah. That's what's up. We have a quiz on Thursday. Everybody's going to do amazingly. It's going to be like super fast quiz, straight 5s. I just believe in it. And on that note, I'm going to figure out how to shut this off because I don't know. Ah! It had information on it. That shouldn't be there. Crap. Nope, nope, nope. Nope, definitely don't click reveal there. Oh, I'm so incompetent. This end is going to be fantastic. Yeah, I showed that earlier, but I haven't showed the key, so we're good there. And I will figure this out. My stream health is indeed excellent. Oh, gosh. Panic. Credit card stolen. Oh, rip. Wonder if I can go back to YouTube Gaming and get it out here. Like, sign out! No. Crap. In-stream on OBS? Yeah, I'm scared to go into OBS, though. It's like Chappelle's still on here. Maybe click elapse time? Yeah, whatever. Stop.